Welcome everyone. A very good afternoon. Hope you're all staying safe and you and your family are taking care of your health. That's kind of the priority now. But even amidst all this, we are happy that you could join us for this session. Like I said, we've got fantastic response. And Vivek, along with Dr. Nair and Gautam, have planned a great session. We've kind of discussed on what are the possible aspects that startups could be looking at in terms of product development. So without wasting too much time, my duty here is to just kind of set the context. So I'm Jaya from the IIT Madras Incubation Cell, representing the larger IIT Madras incubation ecosystem. I have my colleagues Shriparna and Kalyani also here along with me. And while Vivek will kind of be moderating the session and be taking forward from here, just wanted to mention that, we would request you to be on mute while the session is ongoing. We will be opening up for question answers towards the end. If you have any questions, feel free to enter them into the chat box or do raise your hand and one of my colleagues will try to get to you. We have a couple of questions which people had sent in earlier. We'll try to get to that as well. But right now we'll get the session started and it's my pleasure to introduce Vivek to you. Many of you already know him, have interacted with him. His formal position here, of course, is as a design consultant at the IIT Madras Incubation Cell. But we've known him for years now, first as a student at IIT Madras. Then he was working at a research center in IIT Madras at the R2D2 lab. Then he had his own startup, got incubated at IIT Madras. And finally, we really wanted to kind of leverage his experience and expertise. And, he's formally in the role of a design consultant. So Vivek, over to you and, look forward to a great session.
Thank you so much, ma'am. It's a pleasure to be moderating this panel. I'll just quickly start by introducing the panelists. So firstly, introducing Dr. Nair. He is the CEO of Design Alpha and Chief Technology Officer, Advisor at Foundation for Innovation and Social Entrepreneurship. He's an alumnus from IIT Bombay and a veteran in the field of product development. Under his leadership, many novel products in healthcare, communication, industrial, aerospace, and defense domains were designed, and many finding excellent market acceptance globally. He has more than 120 publications, 18 patents, and has co-authored 3 books. Generally, Design Alpha is very well known for providing a holistic support to startups developing products. We are glad to have you here, Dr. Nair. Then also introducing Gautam. He's a other panelist. He's an entrepreneur, industrial designer, and business strategist based in Chennai. Along with his fellow designer Jagan Ganapati, he runs a design studio, Yuga Design, that caters to industry sectors globally. He is a postgraduate from NID Ahmedabad and has industry experience of 12 years, developing 30 plus products. His industry domains are design-led innovation, entrepreneurship, commercialization, and new product development. He currently also mentors several medtech startups that are building the next-gen global impactful solution. So personally, I've known Gautam for a while now. Yuga Design is very well known for their deep user empathy. They really understand the user requirement, and on top of it, they really put a great form factor for the overall product. We are glad to have you here, Gautam.
Thank you, Vivek, and it's nice to see Dr. Suresh again. It's been a long time. Nice to meet you, sir. Yeah.
Thank you. You have to answer all the questions.
Yes, sir. Yes.
Okay.
Sounds very good. I'll just quickly set the context of this discussion. So primarily, we are focusing on startups which are developing a physical or a tangible product. Now, this journey is in many ways different from someone who is developing a software product. And we wanted to explore particularly this type of journey. And in terms of our primary audience, we are focusing on initial stage startups. These are companies which are in their early stages within less than 1 year and pretty much are developing a product for the very first time. Although a lot of the points what we'll take up for discussion will be relevant for people who are in their later on stage or developing the second or third product, but the primary focus area is for early stage startups. And in this talk, we'll try to cover up the complete journey, different key aspects of product development, right from the seed of an idea where someone comes up with starting a particular product, right till the product reaches the customer. So with this background, let's kickstart the conversation. Can you please start with what you do and what would be your suggestions on the roadmap with the key milestones for product development? So let's start with Dr. Nair, and then Gautam, you can take over. Over to you. Thanks.
Vivek, can I share a few slides so that?
Yes, please.
Yeah. I'm just going to make it full screen.
Yes. Thank you, Jay. So this is.
Please let me know when you want me to go to the next slide.
Yeah, sure.
Yeah.
So this, I think to set the context, I thought like I will have some 3 or 4 slides. We can go to the next slide. Everybody talks about innovation. You can go ahead. So normally, you have to know what is the definition, the simple definition. It is process of translating an idea or invention into a product or service. That is the normal definition. But I wanted to add a little bit more on that. I call it as an innovation provided whatever you have done that creates value or for which customers will pay. The idea is like, I may be good in nanotechnology or anything like that. And I think like whatever product I'm going to come up, there will be a market need. If you look at the survey, actually, there are around 58,000 startups in India. And there are, I think, very few hardware products have come out of these startups. And there was an analysis done on that one. What is the reason for the failure or why people have not come up with the product? So you will be surprised, around 47% the reason for failure or they have not come out is there is no market need. So what we are doing is, we feel like this product is good and we come up with the product. So that is not called as an innovation. The innovation is only when it creates value or for which there is customer to buy. So this is very important. This point, the second one, next slide. On a lighter note, if you see, like if in case you fall down from somewhere, what you do is like put a plaster and then put a sling and go up, ahead. So anyone you meet, you have to tell what happened, especially in India, the first question will be what happened. So you have to go on answering this for a few days. So the energy spent by you, on a lighter note, I was thinking like, it can be even the reason for that fall can be printed on the sling itself so that you need not explain. You save a lot of energy. It's just on the lighter note. I think now these type of things can be done on the mask also now, whether you have taken second dose and, all those details you can put it on. The next slide. Because normally, the webinars are very boring. That's why I put that one. It is a very important slide. Whenever you are going to start an activity like an entrepreneurship, I have a checklist which you can do, self checklist. First one is the originality. This is very important. I have been sitting in many forums and committees and all. You can see that most of them are coming up with ideas, somewhere heard, somewhere read. It is like a Me Too type of idea. That's what it is coming up. There is no originality. See, originality doesn't mean that you have to come up with something non-existent in the world. You can think of some incremental innovation. That also will become an originality. Okay, this is very, very important. So, when you go for request for funding and all, you can always get away with whatever you talk about your idea and all, but you are going to put your life into that one. So these points are very, very important. You have to do a self-check. Am I going to add something very new? Second one is prior art status. If you want to do incremental innovation, you have to know what has been done till now. This is very important. So you have to do enough homework to understand what has been done, what people have done. You have to spend enough time to understand. Then only you can think of something extra on that one. Next point, patentability. This I think very well. I stopped patenting because it's not a very very difficult task, because when you are coming up with something new, you can always patent it. So that I will just skip. You have to do market analysis, competitive products. I think I will skip. That one. Yeah, this is very important. Development costs and time. Whenever you are planning to start something, you need to understand how much development time it is going to take. Is it going to take 5 years? Then only I will come up with some product, for example, something for aerospace and things like that, or for space. So do you have that type of time? So this is very important. Many of the startups, after 1 or 2 years, they don't get revenue and they get disintegrated. So this is the normal thing because your colleagues are all working in multinationals, earning a good paycheck. So, you will have a lot of family pressure, parental pressure to leave this one and then go out. So you have to be very careful. You have to think of something which you can get some revenue very fast. The next point, product costs. This is very important. I always used to emphasize on this one, design to cost. See, normally when you design a product, what happens is like you do the design, take all the bill of material, add the cost, and then you add a few more things which I will cover. Then it comes product cost. Think of a situation where you have come up with a product cost in your design, which cannot be sold in the market. It is not competitive. Then what is the use? So when you are coming up with a specification, technical specification, I always insist you also put one line, what is the cost expectation? That is also a specification. Okay. Why I'm saying is like, once you put that as a specification, whenever you are thinking on designs, you can think of alternate designs to come up with the low cost thing. So there, one example I will just explain, there may be a single chip solution, which may be costing probably more. So you have to think whether all these functions are required for you. Can I get away with a small, simple, discrete level circuit? So all those things. Next one point is on the repeatability. This is very, very important. In a lab, if I am the innovator, I can do with my own hand and make things work. Okay, that is what. But when you are starting with a product design, it has to be designed and conceived in such a way that you are not going to handle that product a little later. Initially you will do with your own hands. After that, it will be given to someone else. You will not handle with your hand. There is no opportunity for you to fine tune and also it has to be designed in such a way that it is repeatable. An example is, you select resistors and all. There is something called a tolerance associated with every resistor. This is very important when you come up for the repeatable design. The next one is manufacturability. This is very important. Like you can design a product, you can make a product, you call it as whatever MVP or prototype and all. But finally, what you are going to do is you are going to give these to a manufacturing company to do the volume production. You are not going to sit with them. You are an engineer, you are a PhD and all those things. You know what is the, all the technical details. You have to convert all your ideas to document. And only a document will go to a manufacturing company. So the documentation has to be perfect. And in the document, you say what that other fellow has to do. For example, they may be ITA or diploma graduate. So they will do what you are telling, what you are instructing. They will not use their brain to fine tune or do any other alteration and things like that. So you have to tell pass fail type of thing. They will not do an analysis and so that is what manufacturable documentation has to be. And also I will cover on the design for manufacturability. Whatever you design cannot be probably manufactured. For example, I covered electronic. Let me cover on mechanical. If you are going to do an enclosure with injection molding, so you have to set that design in such a way that the injection mold can be designed and the mold can be taken out and the product will be formed there. Now, all those things, a simple SolidWorks design will not do. You have to really put in your brain based on your expertise in manufacturability into this one. So these are the points which you have to really look at. Yeah, go ahead. The sustainability is, like you are not going to stop with one product. You have to think of what are the other things. So that also you have to keep in mind. Yeah, the standard process of the life cycle, product life cycle development. I will take some 5 minutes on this and then I will stop. First is a concept, an idea. So the technology and all those things, you have done enough homework. And the first stage, next stage is a proof of concept. Whatever idea you have to prove it to others. You feel it is working and you have to prove it to others. At that time, you can use all the lab equipments like oscilloscope, power supply, spectrum analyzer, whatever you want. All those things you can use it. But your idea is to just prove the idea. Okay, you can keep it on a tabletop and then explain to that your idea works. Once that is done, then you move on to the design. This design has to be as close as your final products. So before you start the design, you have to come up with a requirement specification document. That means what is the requirement? System level. Then you go one stage inside, inner side, subsystem level requirement. And what I always used to tell is like, you also specify the standard requirement. What is the standard you want to comply to? That also is a factor which has to be put in during the design. So all those things you come up, then you do all the design like industrial design, looking good, aesthetic ergonomics, I think Gautam will be able to tell, and all other parts will be there, mechanical, maybe RF and IoT, all those things will come, embedded software will be there. Once that you have done, you can go to a proto build. Proto is, I call it as the first one is alpha, the second one is beta. Probably your alpha can be called as the MVP also, minimum viable product also. So you can use at this point of time 3D printing, vacuum casting for enclosure, sheet metal parts. And then, all those things you can do, the PCB assembly, you come up with alpha proto, you give to some of the potential customer, they will give a feedback. You refine that and come up with a beta proto. That is what the proto there ends. You should not go to gamma and the other things. Okay, 2 is enough. So you have to do enough work on the design so that you will end up with only beta proto maximum. Alpha proto is always desirable. So once that is done, beta is done, functionally it is working, then the next stage is pilot build. You are moving to the manufacturing, volume manufacturing, okay? So pilot build is like you build maybe 100 numbers, 500 numbers, depending on the type of product. This pilot build has to happen in the final manufacturing facility. For example, you will be giving to a manufacturing location, so there only it should be get manufactured. What it means is like, once the pilot is built, you cannot change anything. No circuit change, no component change, nothing. No material change. Because the sample of the pilot, you can take it and you give it for compliance testing. Okay, like CE, UL, there are many standards. You have to get the compliance testing done. Once it passes through that, and also you have to simultaneously do reliability testing. That is like, when you are coming up with the product, you have to tell what is the warranty. You cannot go to a Jolsian and get, what is the warranty. You have to scientifically prove yourself. Like you do some highly accelerated life test and then try to estimate what can be the life of the product. Then you have to tell that number. Okay, then only you can give a warranty. It's not like I guess 5 years and then give warranty like that. So there is a scientific way of doing that. Then the commercial products come. So these are the life cycle for a development of a product. I should stop here, and probably the next is what the slide. Can you go to the next slide? Yeah, I think this way I will cover later on what is the product cost, because people used to think like a bill of material is the product cost, but it comes to around 60 to 65% only. So that is what you have to think. So when you think of a product which will be low cost, you have to be very, very, very careful. I don't buy on low cost by doing it within the country locally and all. You have to be very, very careful on that. I believe in lower product costs only through disruptive engineering. That's what I think I will cover maybe in the next discussion. Thank you. I think we can go back.
Surely. Thank you, Dr. Nair. Gautam, you can take over.
Yeah, sure. Just a minute. Do I have the rights for?
Yes, absolutely. Yes.
So is my screen visible?
Yes.
Yeah.
Okay. So I'll just start with introduction. Before that, I just wanted to mention, Dr. Suresh, your idea of the sling for the fractured hand, that was excellent. It very nicely puts what innovation is, a creative way of solving a basic problem. It doesn't have to be completely new. It's just a creative way of doing it that somebody else has not yet done. And that has also got good market acceptance. I really like that example. So yeah, so I'll start. So User-Design is it's a product design company. We have been in the market since 2009, and we focus on a lot of product development and product styling projects. We worked in healthcare. We worked in the transportation sector. We worked in a lot of UI UX, digital UI UX projects recently. We help the entrepreneurs from ideating to end commercialization of the idea. So we work with human factors, usability engineering, product design and development, which is the full from scratch to end. We do just enclosure designs also, where the other companies come to us saying that I just have an basic product done and the user has accepted the product, but I'm not able to market it well. So then we help them with enclosure design. And then we also do prototyping and batch production, which are a part of the product development cycle. So I'd first like to start the conversation with the user. We are a user-centric organization, so we put the user first. But along with the user, it's also important to know that as much as you love your user, you also have to love your business. When you design for the user, you're ultimately designing for a business also. Okay, it has to go hand in hand. And that's where empathy comes in play. So that's why this term, love thy user. Okay, you have to design your products with so much careful attention and what we call a design mindfulness. Okay, it's very user-centric and very reflective in nature, meaning you keep reflective on the feedback of the users, on the feedback of the market when you test your prototypes. And then you come back and redesign and then refine it over and over and over again till you perfect it. So that's why this example over here is given. It's called the Chanoyo. It's a tea making ceremony, the art of tea making in Japan. Okay, most of you must have seen this in a lot of samurai movies, how they, very delicately and very carefully with so much attention to detail, right from the way they walk, to the way they dress, to the way the environment is, the entire user experience is very zen. Okay, so the entire thing is designed. Okay, it's not a part of their culture. It is designed such a way that it became a part of their culture. Yeah, so this is what the first thing that I wanted to insert in everybody's mind. The next is the process that we use. Okay, here we can see we are working with a couple of users. They belong to an NGO, blind school NGO in Meghalaya, and we were designing a product in Shillong for people with blindness for a label making machine. Okay, it's for a device that's used to print in braille, and you can stick it onto any surface that you want, so that they know what that book is or what that product is or whatever. Or they can even stick it on their medicine box. So this is our basic process that we follow. It's IBM's process. It's a very generic design thinking process that most of the people follow. It's called observe, reflect, and make. Okay, observe is you observe what is happening, what the users are facing, the problems the users are facing, and then you reflect on it. Okay, and then you make a prototype. Okay, you see whether that prototype is good enough for the user. You test it with them, and while testing, you again observe, reflect, and again you redo the entire exercise, iterate again and again and again till you perfect that prototype and make that user happy. Okay, so this is a basic process. Now, the industry standard, what we have is this double diamond process that you see here. It's called the discover, define, develop, and deliver. Okay, I'll further elaborate this. So when you come across a problem, okay, it's usually through a discovery, or it's an insight, a hallelujah moment, or you must have come through it, experienced it genuinely in your own life, or it must be something that the market needs. Okay. So what we do is we tend to start a discovery phase where we do a lot of user study, interact with users, we observe them, we see what and all is there in the market to address that problem. Why is the problem there in the first case? That's the most important thing. And then we start and analyze, and we understand what the user needs are. Okay, we analyze those user needs, and we try to make business goals based on those user needs. And from those business goals and the user needs, you start defining the constraints. This is how the product should be. It cannot be not more than this. It cannot be less than this. This is what we have to do for better market acceptance. So before you even start designing the product, all these things have to be done. A lot of people just jump into designing the product directly. So that's the biggest problems why, as Sir was saying, a lot of 46% of the people are failing. Why? Because of this one particular reason. Okay. And then we define the constraints, and then we build a design direction strategy. How are we going to design the product? How are we going to build it? Your BOM, everything comes in that. And then we start building the product. Once you start building the product, the first thing you will do is, with the minimum resource that you have, you will be creating a frugal prototype, or what we call a very basic jugaad type technical prototype, whatever you have. It could also be a bench type prototype, in between a bench type and a first alpha translation product. Okay. And then after you test it with your user, this is what I call here. You prototype, test, refine, prototype, test, refine. You do it again and again and again with your users in mind, in their presence. You test it in their presence, and you get feedbacks from them. And then you build your intermediate technical prototype before your final prototype. And then again, you test that. Once that technical prototype is satisfied, you go for your final prototype, which is with your enclosures, your styling, your branding, all those things comes into play, and you test that again. Once you do that test, you're ready, you finish your DFM activities, and then you go for production. And your trials and all those things will happen during those. So from our estimate, our projects that we have worked on have been from 6 months to 2 years. It depends from project to project. Yeah, so these are something about the company now. These are some of the things that we do. There's the product styling, new product development, and prototype batch production. You can see some of the concept designs that we have worked for companies here. This is for the medical field, and this is purely an enclosure design exercise. This is for a concept design vehicle that we had designed almost 10 years back. And this Braille laptop, which we had designed with IIT Delhi. And there's a lot of, so you can see the user feedback study done over here with the mock-up prototypes to get the basic ergonomic layout and all that. And then this over here, you can see the production activity. Design and production was done in-house for a solar-powered boat that we had done in Chennai. These are some of the other works that we do. And yeah, that's it.
Thanks, Gautam, for the quick introduction. Jamam, I think we are presently at around 4:35. Till about 5 o'clock, we can have a discussion.
Please,
open
please.
it to the panel.
Sure.
Sounds good. So jumping in straight. So like one of the key aspects, what we see that there are many startups which are able to successfully develop software product. Generally, we see that software product development, the success rate is much higher than that of a hardware or a physical product. What would you see as the key challenges which the startups face in this? So Dr. Nair, again, you can start, and then Gautam, you can take over.
You are right. Like software products, apps, and all. Normally you can see like so many products are coming out, but hardware, it is a little difficult. The reasons are many. Like, see, I believe that once the technology is sort of proven, and I think if you follow a systematic process, I think the product should come out. That's what I believe in. So why this is not happening is like we are not really following systematic approach. The reasons are many, because once you get a funding, you want to come up with the MVP as early as possible. So you try to get some evaluation boards from here and there, okay, because your idea is to prove so that you get more funding. So that is one thing, and that is one. And second one is, normally startups, I have seen that they go with the freelancers also. I'm not blaming them. I am not. I appreciate them, but freelancers, they don't really have an idea about the manufacturability point of view and lot many things which are, for example, regulatory compliance point of view. So you come up with some product which cannot go to the next stage really, because it has not followed the systematic requirement. That is what one thing. Second one is like the components also, getting components. If you look at in India, there is no source for electronic components and all. So you have to always import from somewhere. That also sometimes takes time. So it gets delayed and things like that. For example, now the electronic components are not available. The lead times are going to 28-30 weeks. So if you want to build a prototype now, it is not possible. You have to wait till that time. So these are some of the problems, cumulatively contributing to these issues.
Thank you, Dr. Nair. Yeah, good.
Yeah, so there are a lot of issues for startups. It's a really difficult time, especially during the COVID times with the funding and all those things being stalled. I really deeply empathize with those guys. They're very hardworking. They have taken a lot of risks to start something, and it's very difficult. So yeah, the first thing would be funding, right? You have to get your funding right, and in order to form the right team. As Dr. Suresh said, you cannot do everything yourselves or appoint freelancers. You have to work with experienced people. Did you bring that experienced people inside your team, or you hire them from outside? But they have to be experienced, right? The funding also helps you to get the right team, and also takes care of your salary and your basic needs, your bread and butter, right? And another thing is, do not directly jump into building the product right away. That's the worst thing that you can do to the user. Right? There are a lot of people who come to us saying that I've done my product, but nobody's ready to accept the product. They're not liking this. Why they're not accepting this thing? They'll start blaming the user or the doctors or the customers. Right? They don't understand that they have not designed for the user in mind. They're designed for themselves in mind. Right? That their own biases have come forward in the product. Right. So the lack of user study and strategic insight that is necessary in a business, that is completely missed out. You cannot skip your design process just because you don't have the budget or the time to do it. It is necessary that you give that time for that product development process. Most of the software new product development that is happening, user experience design is a big part of it now. There's a lot of design thinking being involved in that, but the process is very agile working process, and that cannot, as Sir also mentioned, it cannot be adopted in your hardware-based product design, because there's a lot of time that's taken for developing a prototype, testing it, sourcing components, working with your vendors, fighting with them. All those things take time. It's not possible to do everything agile method. The internal product designs team, that is mostly the co-founder, the founder, and maybe 2 or 3 interns, their lack of experience will definitely reflect in the product if you don't work with mentors and experienced people. So that's my take on it.
Then one of the key challenges, what we see is that especially there are teams which keep developing product in an endless loop. Even after a couple of years, they're still into their product development activity. So what would be a stage which a startup could define, telling that their product is ready and they should start thinking about the production aspect of it? And also this time, many times in hardware product, we see that startups, when they are developing a product for the first time, it takes a couple of years. Whereas the same team, when they're developing their second product, it happens much faster. So how can they also, the second question on the same, how can they improve this time factor? So Gautam, you can start with this.
Yeah, so the part where you said about the team is able to do the second product much more faster. I've experienced this firsthand with most of the entrepreneurs that we work with, right? It's experience. That's what it is. Everybody learns from their mistakes, And there are good learners, there are bad learners also. So sometimes they repeat the mistake, sometimes they learn from the mistake and they just don't repeat it. So it depends on the from entrepreneur to and the team, right? So one thing I would suggest is to shorten this time is always do your discovery part first. Again, not going into directly building the product, do your discovery, take a good enough time, because that is what will decide whether your product is going to click in the market or not, whether there's going to be market acceptance, right? Have you spoken to your champion buyers? Have you spoken to your champion users, right? Champion buyers and champion users are basically your target audience, right? Have you spoken to them in person? Say, suppose you're designing a vegetable cart. Okay, the solar powered vegetable cart. Lots of products are there in the market now. Have you spoken to a vegetable vendor? Do you think he can afford it? Do you think he can keep it out in the open outside his house? Will products, components from that get stolen in the night? Is he living in a place that is similar to that of an urban person? Okay, of a middle class urban person. Have you looked at the personas of the user type that you're targeting, right? When you're going to try designing a product to sell to a business, every business has a purchase manager, like a hospital has, any hardware vendor, they all have purchase managers. But have you spoken to them? Have you tried to understand, what their needs are, what is the price point they're looking at, what are the competitive pricing, what is their favorite competitor that they like? All those things have to be done in the discovery phase. Once that is done, you get a clear, idea on your business goals. Most of the people, they just directly jump in and they don't freeze their business goals. You have to frame your constraints, define them very clearly. Only then you can move forward, and you can reduce your time drastically in that discovery phase if you do it properly. Otherwise, you'll keep on prototyping and just wonder why nobody's liking my product, why I can't sell. Yeah, that's the.
Yeah.
That's
yes, that's perfectly correct. So whatever reasons Gautam has told, so how can we now bridge the gap? That's what I think we can think of. So I was thinking like, mentors, very, very important. Mentors, it is not like professors, you are academic people, you have to take them as mentors, that is one part. But there are many people available, even free of cost. Like if somebody comes to people like me, I wanted a session, maybe 1 hour, 2 hour session. It's absolutely okay, no problem. Look, we have to only put some time slot. So mentors means who have really gone through these stages. It's not the academicians. That is the technology part. The other part, always, there are many people who have already gone through this one, who have developed product, who have faced all these failures, so that they have already learned. So no need to reinvent the wheel again. So they can always help you, telling like this. For example, you come up with a design. So after looking at the design itself, we can tell like, okay, you should not do like this. You cannot make a product like that. Otherwise, the tool cost is going to be very, very high, exorbitant. So you cannot make it. So why don't you make like this so that it will become? So all those things, I think my suggestion is, till they learn, you take help of some mentors who will be able to help. I think we have many in India and who will be able to help. Yes.
Sounds very good. And any quick thoughts on when the startup should really tell that their product development is completed? Because Apple launches a product every year. So how should they plan this?
Correct. I think I have actually a list of documents to be kept ready and completed when you are ready to launch a product. I think if I explain that, it will go in a few minutes. Like what is the plan? So you should be complete in all these sense. Like it has already gone through compliance testing. It has already gone through reliability testing. I will just give 1 or 2 examples. Like one of the startup, they have launched the product. And after some months, it came back. Actually, the product came back because the not reliability. I think the life got short. By that time, the user cannot use further. So they came to us, and what we did was like we tried to simulate the same design what the startup has done. And we could predict that the life will be only that much. It is easily predictable. And then on that, you start working how the design can be improved, and you get the life extended maybe 10 times. So then we did a redesign of that one, and then we came up with the product. So these simple things, it should have taken maybe 1 week more for further analysis, like further do analysis and come up with a fine tune the design. So only that 1 week has made them get back all their products. So I think those are some of the things which you have to complete in all sense. It is designed and manufacture ready. As I rightly said, you are PhD and whatever it is, engineer and all, the manufacturing is going to be done by a machine, pick and place machine, and ITI person who will not think about your product and technology. So it should be designed in such a way that is what design for manufacturability, designed in such a way that when they follow the instruction what you give, it should work. So I think that level only, it has to come to that maturity level.
Got it. Gautam, you can take on the next one. So basically, like even you referred to in the presentation, user-centric design. It's like a buzzword. We always hear about that word whenever we talk about a physical product. So can you give some more context on what it is and how can startups really adapt that? Also, just adding on, because of your expertise in the same area, that the look and feel of the product. Many times when engineers are developing the product, there is a technology might be really great, but overall as a product, it might not be wholesome. So how do you suggest people can take on that?
One thing is, it would be great if designers, entrepreneurs, the co-founders, and the main core execution team. So it might be 4 or 3 people, I think, mostly. So it's good if they go through some design thinking workshop, right? It is very difficult to implement design thinking by doing a 2 days workshop. Okay, it is not possible. You have to have once you finish that, you'll be more design sensitized, but you will definitely need a design thinking coordinator or a catalyst. A person has to be there to support that activity, to inculcate that innovation culture within your organization, right? That is something that is very crucial for all entrepreneurs, right? Only then, when from the top management team, you're design centric, user centric, that will become a part of the company culture, right? And that innovation pattern will keep flowing through all employees. You will start even hiring people who have that little bit of creative sense, who are looking to design and try to do problem solving and all those kinds of things. You'll start looking for people like that. So at least either have somebody as a chief design officer in your company, or at least have do some workshop or something like that, right? Design thinking workshop where you get yourself informed. That's the only thing that you can do once you, as a startup, right? It's the most important thing you should do. Another thing is, again, for a user-centric design to happen, you have to be empathetic first. You have to walk in the user's shoe, and you have to walk in the buyer's shoe. The user and the buyer are 2 different people sometimes. It's not necessarily the same, right? Now, then you have to have a reflective type of practice, right? You have to go reflect back, do your homework again and again, go reflect on what the user said and all those things. And then from day 1, you have to test your prototype with your end user, and also interact with your buyers right from the beginning. When you're building the product itself, go and find out those buyers that who can give you pre-orders in the future. When you're ready for your first prototype, the testing and all is going on, you go and show them the demo and say, see, I'm taking pre-orders now. Can we work together now? So are you ready to purchase? So that relationship starts right from the beginning. Okay. There are some cases where you have not, you don't need to raise investor funds. Okay. You can just get those pre-orders and fill up your purchase order. Yeah. Another thing, which is I find is a very big difficult thing for engineers and researchers. It's letting go of the my baby syndrome. Okay, it's basically you have to empty your cup. Okay, you have to throw away all your biases and everything, and you should not have your own bias, and you have to be user biased, you can call that, right? End user biased. You should be open and ask, first of all, why is there a need for such a product? Even if it's your own product, why would anybody buy it? Will you buy it? If you had 1 crore rupees with you, will you put the entire 1 crore rupees into your project, or will you take little bit money and put it in your own pocket for your house expenses? What will you do? That will determine your risk taking capability and how much you believe in the product. That's very important. And another thing, I think you were talking about the industrial design part versus the and the user experience part, right? So one thing has to be understood, that industrial design is not about aesthetics. Okay, industrial design, user experiences, it's not about what's the feel factor or the look factor or anything like that. It's about the experience while using the product, right? It's about form and function. Most people just look at the beautiful forms and the marketability of that product, and then say, oh wow, I want to own that product. They buy the product. It's a crap product. You can't use it. The knobs are somewhere. They turn the knobs, it breaks off. Lots of funny things are there in the market. They are basically art pieces. They're sculptures. They're not meant for functionality. So first, clear out your functionality aspects, the ergonomics, the basic technical function of what the product should deliver. Is it doing that? That's the most important thing, right? UX is also not about aesthetics, right? I'll give you an example. Everybody knows about the Indian truck, right? The lorry that you're seeing on the roads, right? They're very colorful, yellow and orange and red and blue and whatever color you can imagine, fluorescent. There is a woman bathing in next to the river, and the waterfall is there. All those things are there in the back of the truck, right? So that's custom made. Do you know why that is done? It's because most of these drivers, they are away from their home for a long duration, sometimes months in time. Sometimes they go 2 or 3 months once they go home. And all those pictures that you see on their truck, they are representations of their hometown, the greenery, the waterfall, all these things are representations of that. And they decorate with all those ornamentations and all those things. They're all to remind them of home, because that truck is where they spend most of their time. Okay, they live there, they have baths there, and they have food there, their conversations are done there, and because of that, it is their second home. Okay, but now what has happened? Just imagine, we have taken that user experience and thrown it out of the window, and in the name of designing stylistic looking Ashok Leyland truck or whatever Tata's truck that you have here, all those European trends and European aesthetics and all those things, right? We have thrown out the user experience. Now the driver is not allowed to do any custom paint job or show the reflection of his identity on the truck, right? They are asked to don't do anything, so it will spoil the brand name. Okay, keep it empty. So these kind of problems are there. So aesthetics is all about trends and cultures and all those things. So it's just used for making the product marketable, that emotional buy-in need. There's nothing else to it. If once that is the thing, if that's the only thing that is left in your product, you have successfully satisfied the user, the happy user, happy customer, then all you need is a design agency or an industrial design on board in-house to do that job. That's not an issue. Yeah.
Fine, thanks. Sir. So, Dr. Nair, I think we can take up one last point. This is a little beyond the product, about the product costing. I think the slide what you also had prepared. that costing will only come down at scale and various processes are possible, but that requires high investment and might not be practical at the initial stage.
Yeah.
So how do you suggest that startups can really plan their initial product cost? And also more specifically, like for example, what is the range between the bill of material cost to the final selling price? For example, Apple, it's a very different factor.
Yeah.
Whereas, automotive industry, it's a different factor. So it's a art to find the price of the product. So can you give some guidelines on some thoughts on that? Thanks.
I think it's very, very important question. Like, I told you, like along with the specification, technical specification, you have to put one more specification, what is the cost? That is bill of material cost. Okay. So, for example, I think I have a lot of examples also. I will just give that one. It's like a two-wheeler identification, like the car, we have that identifier, right? In a railway station, if you see so many two-wheelers are there, all are similar looking. You don't know which one is your two-wheeler. So you can, in the key, you can just press and you can get the identification, where it is. But the only problem is how to lift it from that side. That will be another problem. We will leave that one. So you only identification. So then when they came to us, actually, they had something in mind, the cost in mind. Because nobody will buy this type of identifier like a key, which will be above maybe 800 rupees or so. So that was their target. So 800 rupees, then we thought like bill of material cost should be around 500, 550. So that is the range for that one. Automotive it is less, but here and there it can go. So single chip solutions are available. Like you can buy a single chip and then put it all these things and then make it work. Then it was not coming to that level when you put all the peripherals and all, because there is a mechanical enclosure and industrial designer will put something there. So that is another one. So what we did was like, so it is a specification, cost is a specification. So we thought we can use transistor and coil and come up with that the same design. Okay, when we did the discrete design, we could meet that cost. So it is in the market now. I don't want to tell which brand and all, but it is in the market. So easily we could achieve that. If that target cost was not given at that point of time, I would have also gone with a single chip solution very easily, peacefully done the design and things like that. So that is one thing very, very important. So once you have that, see, other products are at some level. So it is not like it is impossible. So there are already some people with a similar type of products. So you know what is the cost and what should be your cost. So you can come up with some innovative solutions on this one, probably disruptive, type of thinking, so that you can meet that cost. So that is one. Second one is like when you initially, if you want to do a few prototypes, you can really go for 3D printing type of enclosures and all, but you have to think or plan the design in such a way that when you go for volume manufacturing, you have to really do some calculation. If you are planning to have a plastic injection molded type of enclosure, it will be damn cheap later on. It may cost 2 rupees or 3 rupees or something like that when you go for. But the problem is the tool cost is very high. So you have to know how many you are going to make it. Otherwise, you go with the other many types of manufacturing is possible. Like vacuum casting is one. Vacuum casting is good, provided you do a very good design. See, the SolidWorks design will look perfectly all right. And when you get the vacuum casting done for initial 1 or 2 days, it will look good. And after 1 week, slowly it will bend and the holes will not match. So all these things you have to take care. In the design itself, you put the necessary rips without making the product look bad. So all those things, I think if you can approach a support of some of the good designer, you will be still able to go with. For example, volumes of 200 numbers and all, we can really go for this type of processes. So you have to do an analysis, what you want to achieve, how much money you have, whether you are going for the volume manufacturing. So based on that, you can plan that.
Sounds very good. Jia ma'am, should we?
Yes. So what I would suggest is, Vivek, let's open it now and see what kind of questions we have. So if anyone would like to ask a question, they can unmute for now and ask that question. And in the meantime, if anyone has, they can either enter it into the chat box or just raise their hand. There was a question which we had already received, Vivek. I think this has been covered, but basically they wanted to know, this is David Roshan Cyril. I don't know if he has joined the session today. David, are you online?
I don't think so.
Yeah, I did see him, but so his question, Vivek, was something which we've covered, which is the areas to focus during the product development itself so as to be manufacturing ready. So very quickly, if we could kind of just again maybe iterate on that.
Yeah, Dr. Nair, can you take that up?
Yeah, design for manufacturability, basically. That's what
Correct,
I think.
correct. Yes.
Mainly. Yeah. See, in every aspect, for example, let me start with an electronic PCB design. So PCB design, when you do the Gerber design, because schematics is okay, the next stage is you come up with a layout. You have to take care of many things like manufacturability. For example, finally, the components will be placed by a pick and place machine when you go for volume manufacturing. Okay, so this is the machine needs to understand some of the reference points. So you have to give sort of a fiducial some marking so that the machine will understand that this is the reference. With respect to that, I have to keep the component here. So those things you have to take care. Then the tracks. There are some IPC standards. You cannot just put tracks at whatever width you want and all. It all depends on, there is a specific requirement, like what should be the gap, what should be the width. Based on current flowing also, you have to define that one. So all those things you have to take. That is all on electronics. Then what type of components you can keep it on one side. This is also very important. For example, you are coming up with a PCB where there will be components on both sides. So you have to identify similar type of components only you can keep it on both sides. That is one. Nowadays, people use micro BGA, ball grid array. That is like, normally earlier, the chips are having the connectors or whatever pins on both sides. So you will, using a lens or microscope, you can see whether everything is soldered properly. Nowadays, everybody uses advanced ICs or micro BGA, BGA and micro BGA. That means below the bottom of the chip, the pins are there. It's like a ball. So once you place it, that's all. You cannot know whether these are all placed properly or not. So that for that purpose, you have to design the PCB Gerber in that way so that it will properly put on that. There are some methods like X-ray and all. If you want to really check whether it is sitting properly, you have to go for X-ray and all. Let us leave that one. But so all these things on the electronic side. Then, the regulatory compliance point of view, for example, ESD, electrostatic discharge, you have to, when you do the design, the schematics is okay, but you have to additionally put all these electrostatic discharge diodes so that even if some lightning or some high voltage comes, it will not affect the circuit. It will be bypassed. So that is one. If your circuit is having digital and analog circuits, you have to put a proper grounding in a regular fashion. That is all in electronics. And mechanical, I think, based on the like the process you want to follow. Sometimes you don't want to put a lot of money in tool, but you can raise the product cost by a little bit more, than you can go for sheet metal type of designs. That will require a temporary tool only. You don't require heavy tooling. But only thing is the look may not be good, because sheet metal parts you cannot get any profile of your wish. There are some constraints on that. So in order to overcome that, you put a sheet metal, and over that you put a plastic small parts, like a fascia. So for example, a display is there. Only that display part you put additional plastic parts so that it will look good, because people will really look at that point. So those type of techniques have to be done on design for manufacturability. Then, as in a normal manufacturing process, it starts from one stage, it goes stage by stage, like it will keep the component, it will do many things. We cannot wait till the last stage to happen before you test up the circuit, because you have to know at various interim stages, is it okay till now? Is it okay till now? So that, if some problem is there, you can correct it there itself. So in order to do that, you have to provide some extra pads so that some sort of a pin will go and hit there, and then you can do sort of a multimeter, for example, a multimeter type of thing. Intermediately, you can go and check whether till now it is okay. So those type of patterns also to be included in the design. So these are the things what normally we have to do.
Thank you.
There is a follow-up question to that, Dr. Nair, since you were talking of regulatory aspects and so on. So I have a question from Anita, who asks, where do we refer to the standards that our product should comply with in terms of the certification? What would be a good source for that?
Yeah, this is a tricky question. Like, the best thing is try to identify similar products already in the market. Okay, so if you go through their data sheet, they will specify what are the compliance it has already complied to. That is the easy reference to start with. Then we can go on working on that one. For example, if it is a electronic product or biotech or healthcare product, there are some standards already there. IEC standards are there, 60601, part 1, 2, and things like that. So that we can get help from some of the experts who are already in this domain. But my plan normally, I used to advise, like, you first look at similar products. Then you will get an idea about what type of range you have to look for these compliances. I think there is a hand raised by some.
Yes, so there is Prem from Innovate. Do you want to go ahead and ask a question, Prem?
Yeah, thanks, Jay, ma'am. So we were also at a juncture on whether plastic-based, like the product, or metallic sheet-based product. But one concern we had was, like, with the increasing regulations on plastic, would that interfere with our mass production? Like when we reach the mass productionizing, like we would have reached, but with this increasing regulation, I mean, if that impacts, then it's a big risk. So I'd like to hear your thoughts and latest trends. I mean, when we consider plastic-based.
Yeah, I think in future, probably not in immediate future, I think. So in future maybe, but now there are a lot of plastics available, environmental friendly, and UL safe, ultraviolet radiation safe. All those things are available now. Not only just normal common PPE type of thing. There are materials available as per your requirement. We can always identify those things. So that are injection moldable. So there are absolutely no problem on that. Yeah.
Okay, thank you, sir.
So one question, Gautam, maybe you could take this up. This is from Krishna of Diverse Labs, who asks that product development is a slow iterative process, right? I mean, this is something that we've again discussed. But by the time the product is completed to launch in the market, the market and its priorities have changed. So how do we address this gap?
Yeah, so Diverse Labs, yeah, I'm aware of Diverse Labs. They are doing some pretty good work. I understand there is that market gap is there, and technology is rapidly growing, and it's too fast to keep tabs, and it's like a catching game all the time, right? So that is bound to happen. You cannot avoid it. But one thing is for sure: if you have designed again for your end user and your end buyer, your product will have that edge by the time it's released, which the other person, when the new technology they're adopting to, might not have looked into. That is my take on it. Definitely, you can address that gap by building faster prototypes and testing faster, right? That's the only way you can clear that gap. Otherwise, you'll have to be, as your innovative idea has to be strong, and of course you have your patents and all those things to protect you from when you enter the market. That's the.
Yeah. So there was a very similar question from Ajit Kumar, who was asking on, his question is how to overcome with our competitor. I assume what he means is, how do you always stay one step ahead of the competition? Is there anything further you would like to add to what you've already indicated?
So when you're what we call benchmarking, we always benchmark based on the competitors. If you're introducing a product into the market that's already a competition heavy, right? So always try to see what they're lacking. Okay, and go and talk to the users of those products. Find those users and see what are the problems they are facing. Talk like a service engineer. Talk to their service engineers. Talk like a service engineer to the customer. And see what are the pain points that they are facing. And in your product, you address those pain points and build a better product. It's as simple as that. And of course, you have to make sure that the product competitor that you're looking at, their technology is up to date. As the previous questioner had asked, right? The gap that can be solved even in this kind of situation, right? They might be outdated or they might be just 2 or 3 years back in the technology aspect. You can become updated and you can release your product.
Are there any further questions which we can take with our panelists? We are already a few minutes. Yes, so we have Pranit Mehta, who's, I will just scroll to the question. Yeah, in case of large size competition, how do we deal with them? There's quite a lot of gap in terms of access to the resources.
So that's for me.
Either of you, whoever, both of you can kind of, we'll start with you, Gautam, and then Dr. Nair can add. Yeah.
Yeah.
Basically large, the large industries.
The answer is the same. The answer is the same. We have worked with startups who have been competing with MNCs. Okay. Now, one really beautiful thing about India is that we have that capability of, that surprise element when it comes to innovation. Our creativity is also coupled with one major thing, that is our price. Our product prices can be much lesser than that of the MNCs, and also you should also look at the service design aspect, right? So most MNCs do not give personalized attention to the customer. You can do something like that, give them more attention. They will definitely come to you. There are a lot of startups who have come up like that, and MNCs have had to leave the country. I have worked for a startup like that. The moment the product was launched, the competitor realized they couldn't compete with them, and they left the country. And now when we are trying to, with that companies trying to enter into the US and the European market, they are trying to use their patents to protect themselves and not allow us to enter the country, allow the competitor to enter the new startup to enter the country, right? So these kind of things will happen as long as you are designing for price, because today the market is that nobody wants to spend beyond their means just to be associated with the brand. That's not the case anymore. If your product is really good and you have addressed all the user needs and you have done your design patents and your intellectual patents properly, you're definitely good to go.
If I can add on that one, I will just
please,
case study. I think that may be better. See, there was a multinational, actually. They are very good already in the market. It's like a inventory management device. It's like, the barcode scanner. It's a heavy barcode scanner. It's around 600 grams. So there is a barcode scanning here, and it's quite heavy, because many things were there. And this has got a Wi-Fi connectivity, so that, it tracks the labels, and then this is given to it collects and then gives to the server there. So that was the multinational thing, and we did a lot of study, and we, as Gautam said, we try to understand what are the pain areas of using those things. So one of the thing was, like, they told like it is heavy. The users said like it is heavy. So this is normally used in US mainly, in the malls and all, like Indian students, we go there and get $10 per hour type of night job. So you take this device and go there and do all scanning of all the products in the shelf, and this gets sort of an inventory. So then we found out, like, when this is normally put like that, and when they sit, it touches the ground sometimes, when they put it hanging like that. So we identified the pain points. Then we came back, and for the startup, it's not startup actually, it's a good company, and we designed what we did was like, see, the first thing was 600 gram, you have to go on, using this inside the rack and all. So what we did was like, the scanning part, we removed it. We made it like a pluggable type of thing. Okay, you can either use it with that as a normal device, if somebody wants to use it like that. Otherwise, this plug, a small thing, that's a reader or scanner, that can be taken out. It can be put on the finger. Okay, so that the heavy thing, you can hang it somewhere here at the hip or something like that. Okay, in the belt itself. And it has become so convenient for them. They can do it very, very fast. And because and it was so nice, like it's a small ring type of thing. You just go on doing this, and this was a beautiful experience. We received a lot of appreciation on that one, thinking in that way. And also we made in such a way that, in US, there are right-handers as well as left-handers. So we designed that plug-in thing so that, it can be used for right-hander or left-hander. We just twist it. That's how we made it. Then that's how, I think the production, it went to around 60,000. Each one costing around $800. So you can think of the business which is brought only because of this innovation. Because, it has become so nice. So that's how you can, I believe in only through some intellectual, like creativity, you can beat all these multinationals. If you,
including the larger players. Right. So maybe Dr. Nair will end with this last question with you.
Yeah.
So the question again is from Anita, who's saying that they're finding it difficult in reducing the BOM even after a proto build. Are there any guidelines or suggestions for them?
It's a very good question. See, what you have to do is you have to do a value-added value engineering exercise. You have a product, you bring in some external people who doesn't know about your product. Okay, then you try to first start with all the functionalities. Now, what all functionalities are absolutely required. Absolutely required. Okay, the rest of the thing you remove that. Then you get on to every component. For example, there is a screen, for example. Is this screen required? Absolutely required. What is the purpose of that screen? It is only to display, or any touch screen requirement is there. If it is, can we avoid that one? Okay, so like that, you have to do value engineering for every component. For example, you have a mechanical sheet component, which costs maybe 200 rupees. So can I replace this with a simple plastic one? The tool cost may not be very big, because when you are going for volume, you can get amortized that one. So which will become 2 rupees. Compared to 200 rupees, this will become 2 rupees, the product cost. Of course, the tool cost will go up, that you have to plan it properly, like amortization and things like that. So like that, if you are able to do a very good exercise, maybe 1 week exercise with some people, external people who doesn't know about this one, because so that they can argue. See, you will always argue for those features. That is the inherent thing, because you are the designer. So you have to bring in someone who is your enemy, like who will always question you, why this is required. Can I eliminate this one? So one example I will just give and then close it. There was a system where there was a keypad, a specific keypad they have designed for that one, that purpose. So our question was like, can you remove that keypad? There was already a screen. Can we make it a soft screen keypad, so that physically you remove that $10 thing? Okay, and only thing is you have to put more software, so you create a virtual keypad. So those type of things. So many such what is that called, ideas can come once you brainstorm. I think this is very important. You can do that, and surely you will be able to bring down.
Thank you so much. Vivek, do you want to close with a few words, and then I can hand it over to my colleague Sriprana?
Yeah, definitely. It was very insightful, Dr. Nair and Gautam. I have learned a lot of things, and I'm sure that a lot of people would have really grasped a lot of points, especially that a lot of the key aspects were addressed on. So thank you so much. I'd just like to also inform the participants that we will be starting from the coming month individual sessions where startups could register for these clinics, where we'll have external experts, for example, Gautam from Pcb Design and Dr. Nair, and various other external experts we are inviting for these. You can take a look at the experts and then register for these events. where you can have one-on-one discussion, and it could be pretty much a session for around half an hour. So that is something what we are again planning to start in the coming month. Yeah, Jaya, you can take over. Thank you.
Thank you, Vivek. Sriparna, would you like to say a few words of thanks and to our speakers?
Sure, ma'am. Thank you, Dr. Suresh and Gautam, for taking your time off and engage with our startups. So I think this was a very engaging and interactive panel discussion, and I'm sure all of our participants have benefited. So I would also like to thank Vivek for moderating this engaging discussion. So on behalf of our incubation cell, we would like to offer you a token of appreciation. It is one of our startup product, and we will be reaching out to you separately by email to coordinate the delivery of this product. So lastly, thank you participants for staying through the session and keeping it engaging with your questions. Thank you.